talk about logarithms, what they are, and how to use them. Now, when it comes to logarithms, they're very difficult to explain in common sense, but the best I can do is they undo exponents. And you'll see this as we talk about the rules, properties, and we see examples, but just keep that fact in mind this whole entire time, and it'll make a little more sense. So before we start with any of the rules, let's first draw a chart just to see how the log works. So we're going to say y equals log of x, and we have our x and y plane here. What the log is going to look like is something like that. And right at this point where it touches the x-axis, this is going to be x equals 1. So this gives us a rule that the log of 1 equals 0. So that's a little important fact to keep in mind. We'll talk about that again later. And then we're going to talk about one more chart before we move along. And that's going to be the chart of y equals e to the x. Now what this chart is going to look like is similar to an exponent. We're going to see this gradual increase. That's just because e is a number. We call that Euler's number. And it's just being raised to the exponent. So, important detail here is that at x equals 0, this equals 1. And we can see that with e to the 0, anything to the 0 power is equal to 1. So before we move along, just keep those two facts in mind. These are two important functions that we're going to be working with over time. So it's kind of important to understand what they look like on a chart, and that they're not just rules that we're simply abiding by, that they do have application when it comes to charting. So with that beginning in mind, let's talk about the general form that we're going to see logs in. So what you're going to most likely see when you're starting with logs is you're going to have the log, you're going to have the base, which we'll just call A. Let's actually call it B just to keep things simple for base. You're going to have what you're logging, which we'll call A. Then you're going to have what all this is equal to. And we'll call that x, just for simplicity's sake. How logs work is you have this form to start, and you're going to be transforming it into another form that you can understand a little better. So what this is going to look like is you're going to take your base, we'll write 1 by that, you're going to raise it to what it's equal to, and then it's going to be equal to this third part. So again, that might not make sense, but let's just write it out. So we have the base, which is b. We have what it's equal to. We're raising it to that power. And then we're setting that equal to what we're logging. So these two forms, we can move back and forth and go from log form to exponential form, whatever works better in the situation. But this is the essential form that you need to know when it comes to logarithms. This is how you'll work around problems and how you'll apply it to equations and solving for answers. So just study this relationship back and forth, and that's going to bring you a long way when it comes to logarithms. Moving past this, let's write out some examples. And then I'll give you guys a second, and then I'll go over the answers. So let's go over 3 examples here. Let's say for the first one, we have the log base 2. We're going to log x is equal to 3. The second one, we're going to have log base 1 over 2. We're going to be logging 1 over 8. And then we're going to try to figure out what that equals. And for the last one, we're going to have the log base 3. We're going to be logging 2x plus 3. We're going to set that equal to 2. So pause the screen, take a minute to work on these, and then I'll give you guys a little explanation and we can walk through it. So hopefully you guys got a chance to work on that. We're going to use our general form on the left over here. We're going to apply it to each one of these equations. So we know that we're going to start with the base, which in this case is 2. We're going to raise it to what we're equal to, 3. We're solving that for x. So this is 2 to the third power. Did not write the best, but we know that 2 to the third power is 2 times 2 times 2, which is 8, and that's equal to x. So that's your answer for x. So this looks like log base 2 of 8 equals 3, just by plugging x into the equation. For this next one, we're going to take the base, which is 1/2. We're going to raise that to the x power, and then set that equal to 1/8. We get more into the weeds of the algebra, but this is a simple example just so don't have to make it too complex. 2 times 2 times 2 is 8, so this is to the third power. 1/2 times 1/2 times 1/2 is 1/8. So we know that x equals 3. We can plug that in to say that the log base 1/2, what will be log of 1/8 is equal to 3. And then for this last one, we have some algebra that we're going to be applying. Either way, start the same. Take the base, take the exponent of what we're setting it equal to, and we're going to set it equal to the parentheses, which is 2x plus 3. So this is saying that 9 equals 2x plus 3. Subtract 3 from both sides, 6 equals 2x. And this is saying that x equals 3. 6 divided by 2 is 3. So we can plug that x in, and we get log base 3 of, let's see, 2 times 3 plus 3 equals 2. And this will be log base 3 of, let's see, 2 times 3 is 6 plus 3 is 9 equals 2, which makes sense because 3 to the second power does equal 9. So that checks out. So this is a very important fact of logarithms, which you need to know just to be able to work around the general cases. So study the relationship back and forth, and that's going to bring you a long way in working through these basic problems, and it will help in future graphing problems and equations that you're trying to solve. So now that we know the basics of the logarithms, I want to go over the main rules that you need to know when working with them, because we know how the general form works, but in applying it to other math and multiplication, addition, there's all these unique relationships which are very important to understand. So to me, there's about 6 main rules. And we'll talk about them one at a time. Then we'll do short examples of each one to solidify understanding a little further. So for the first one, we're going to have x times y. Okay? Just 2 variables multiplying each other. Now if we take the log of x times y, these can be any value, whatever you decide for these variables to be. When you take the log of 2 variables or 2 numbers being multiplied by each other, what that's going to look like is the sum of the independent logs. So the log of x times y is equal to the log of x plus the log of y. So that's just 2 different ways you can kind of write it back and forth. But when you often take the multiple of log of x times y, it's going to be easier if you work it out in terms of log x plus log of y. It makes algebra work out for more problems, and it makes the answer just come a lot smoother and without looking so rigorous. So for this next problem, we're going to have x divided by y. Okay? And now if we take that log of x divided by y, this is equal to the log of x minus the log of y. So just like multiplication gives you addition of the 2 variables or 2 parts of it, when you take a division, you're going to take that first value minus the second value instead of adding it like in multiplication. So multiplication and division typically just go in the opposite way of each other, so it's a little bit of an easier way to remember it. Instead of adding, you're going to be subtracting when it comes to division. Now let's say we have x to the y, and this is going to be one of the 3 essential rules, I would say. I'm going to say 3 through 5 is pretty essential in working through problems. So say we have x to the y. If you take log of x to the y, the exponent here is going to be coming down to the front. And you're going to keep the base as the log. So what that looks like is the log of x to the y equals y times the log of x. So we can see how that works out when doing algebra with exponents. Typically it can be very difficult to solve if it isn't just an easy problem like 1/2 to the third equals 1/8. If there's more rigorous math that comes down to it, this is going to help you a very long way because you can type in log in the calculator and get that value. However, it's a little more difficult when you have exponents to try to work out that difficult algebra. So for the fourth rule, we're going to have E. And E, we stated, is Euler's number up there, which I think it's about, right over here. I think E is about 2.7. That might be off. But that's Euler's number. There's a lot more decimals. Just like pi is a number, but we just give it a symbol because it's used so often. So when you have Euler's number, there's a specific log for it. And we call that the natural log. And you're going to see it in this cursive L and then an N. And when you take the natural log of E, that's equal to 1. Now that might seem like just a random fact. It does come into play in future applications of logs, but for now it's just kind of a random fact. That's important to know, but it is one of those essential equations I would recommend remembering. You might not learn about Euler's number right now, and that's fine. Just know that the natural log, which is log base E of the Euler's number, which we represent with E, is equal to 1. Okay. So for the fifth one, it's a fact that we talked about earlier, but we're going to have let's see here. We're going to have 1 to start with. We're going to take log of 1, and that's equal to 0. Now when I'm saying log without specifying any base, we're just going to assume log base 10. That's just kind of the basic number. You can have all kinds of bases, whatever works out for your problem, but log base 10 is kind of the default. It's what we assume. So if just writing log by itself doesn't make you feel comfortable, you can put the little 10 down there for the base. However, when you say log by itself, it's just implied that the base is 10. So we can see that 10 to the 0 power is equal to 1. So the math works out. But you'll see log of 1 very often because 1 is a number that just shows up all throughout math, all these complicated equations that you work out. So knowing that the log of 1 is equal to 0 is just an important fact that gets some of those difficult numbers out of the way right away. And the last rule, we're going to have 1 over x. And we're going to take the log of 1 over x. And we'll assume log base 10. Again, it can be any base, but it's just an important thing just to understand that base 10 is assumed. And this is equal to negative log of x. Now this is kind of like a restated fact, and I'll show you why, but knowing that the log of a fraction is the negative log of the denominator is an important fact, but it's only true if the numerator is 1. And we'll give a little explanation of that right here. We know from our facts up above that when you take the log of a fraction, you're going to take the log of that first part, which for this would be log of 1, and subtract it by the log of the denominator, which is log of x. And we know that the log of 1 is 0, so then we can say that this is equal to negative log of x, which is our fact. So this is an example where knowing that the log of 1 is equal to 0 is an important fact and can just help you move along in the math a little easier. So now we stated all these logs. Let's go through an example of each one quick, just to see how they actually work. So for first one, let's say we have log of 2x. Knowing that we have log of 2 times x, we're going to have log of the parts adding to each other. So log of 2 plus the log of x. Okay. Now for the next one, let's have the log of 4 over x. And this is similar. We take the log of the first part, which is 4 in the numerator, but then we're subtracting by the log of the denominator, which is log of x. Okay, for the next one, let's take the log of 2 to the x. And what this is going to look like is bringing that exponent to the front. And I'd say this is probably the most important fact of logs. So if you take anything from this video, take rule 3 down and just remember that when working through problems. We're going to take that exponent to the front, and we're still going to be taking the log of that number at the base right there, which is 2. Okay, for 4, let's say we got the log of 2e. And, oh, yeah, let's make sure we write out here that this is the natural log. It can't just be any log. So, natural log of 2e. And that is going to be equal, we're going to use rule 1 for this one. We're going to take the natural log of 2 plus the natural log of e. And we know that the natural log of e is equal to 1. So this is the natural log of 2 plus 1. Okay, for the next one, it's pretty straightforward. Just, well, not the natural log, but the log of 1 is equal to 0. The fact you just need to know, there's not much more to it. Just when you run across it, it is pretty good to know. If we have log of 1e, we can see that that just works out to be 1 as well. So, I mean, you can kind of work around the multiples and figure out how all that works, but there isn't much more to rule number 5, but it is still important to know for when you run into a similar problem. Okay, let's say we take the log of 1 over 2x. So we could instantly kind of jump to what we saw here. Well, let's actually work this one out with the prior rules. So we're going to have the log of 1 minus the log of 2x. And now this is interesting because we have to do more for this one log here. So we're still going to have the subtract, but log of 2x is equal to the log of 2 plus the log of x. So putting this all together, we're going to have the log of 1 minus the log of 2 minus the log of x. So you can see where multiple parts of these rules kind of come into play with each other, and you need to know every single rule to be able to work through a full logarithm. So it's important that you know rules 1 through 6 and not necessarily just important rules of 3 through 5. Those are the ones you probably see the most often, but 1, 2, 3, 4, 5, and 6 are all very important rules in their own right and are necessary to be known to be able to work with logarithms proficiently. So yeah, a couple facts here. We know that Euler's number, rounding it, is equal to 2.718. So we said 2.7 up there. If we want a more specific number, Euler is about 2.718. So when we have the natural log, that is log base 2.718, just so you can undo Euler's number basically. Okay, we're going to have the natural log of e to the x is equal to x. Now this is a kind of a weird fact to understand, but kind of the way I'm going to describe it to you guys here is in 2 ways. First, if you have the natural log and e, they're meant to cancel each other out. So you can kind of write it in that way. If you just want to cancel it out, you know that log brings x to the front. You can definitely describe it that way. It's not the most mathematically sound, but it is pretty easy to remember. The other way, which we'll write over here, is how we understand exponents in general. So we're going to have x to the front, and we're going to have the natural log of e. We know that this would be equal to x times 1, because the natural log of e is 1, which just equals x. So a couple extra steps that are important to know. However, after you've done it a while and it's not expected for you to show the log proof, it's just an easier way of kind of working about it, and it's a bit of a mental shortcut, saves you a lot of time in the long run. And our last fact here is we're going to have e to the natural log of x. Now this is something that's kind of out there, and I just want to throw it at the end of the video. This is something you will see as you go further in math if you really get into it, into the algebra, into working with logs. But in the same way that I described earlier, just e and natural log cancel each other out. So the math behind this is definitely a lot more complex, but that's the best way that I can describe it. So the first way I can show you guys a proof, this one, just know that e to the natural log of something, the natural log and e are going to cancel each other out, and you're just going to have what's ever left in that parentheses up there. So this is it's just kind of an out there fact that's important to know. And I guess looking at it further, we can look at e to the natural log of xy. And this is something that might seem confusing at first, but if you know that e to the natural log just cancel each other out, we can say that this is equal to x times y. So you're not leaving any logarithms in the equation. You're just getting rid of that e in natural log. So these last facts of natural log and taking that to Euler's number to some exponent, that's important to know. However, it's also important to know that when you take e to the power of a natural log of something, those also still cancel out. So that's kind of a sideway fact. If you haven't encountered that, your teacher isn't worried about that, don't look too into it. It's just something I wanted to introduce because you do run into those problems in the future. In recap of everything, just study the general form of logarithms and then go over the rules. So you can see that log base of b logarithm a equals to x is transformed into b to the x power equals a. You can work about that with algebra, plenty of ways to kind of manipulate those numbers and make them work out. And then you have 6 pretty important rules here. There's definitely more rules of how logarithms work. However, these are the 6 most common that you will see, 1 through 5 especially. But I think 3, 4, and 5 are very important ones that even past just testing out this information will come in handy when you work on higher classes and calculus and all those other higher mathematic classes and you're just working through a bunch of numbers. So study those if you're really interested. Just try to remember 3, 4, and 5 for your own good. However, beyond that, you should be set for logarithms now. Hopefully that cleared up some information. They can be very confusing and that's understandable. The way you're going to get better at it is with practice, practice, practice. Bring up more problems and use the rules that I talked about today and the general form to work through those problems. So thank you for watching, guys. I hope to see you in the next one. Make sure to like, subscribe, share the video with your teachers, your friends, and rewatch it again. Take care.